We are going to learn a very fascinating topic in mathematics today, and it is about learning the concepts of probability. And the reason I call this as an exciting or fascinating topic is because this is one subject that has such a wide application in the industries, such as casinos or actuarial products. There are a variety of industries that purely depend on the theory and concepts of probability. And if you did not know, probability, it came from the world of gambling. It came from casinos. All right. Now let's take a look at what do we know about probability in our daily life. Okay. So take a look at this word chance. We use this word a lot in our daily life. For example, when we say that there is a chance of 30% rain today, or when you say that I have purchased a lottery ticket, what are the chances for me to win? In both of these examples, unknowingly, we are using the concept of probability. Okay. Now, how do you put a number to a chance? And that is where we convert the number chance into a probability. Okay. And we will learn about that today, that how do you put a number to a chance, or how do you calculate the probability of an event. All right. So probability of an event, it is defined as P of E. Okay. Where E is in parentheses. P stands for probability and E stands for the event. Okay. So at this moment, we need to pay attention to some of the very basic terms that are used in calculation of probability. And the first one is called an experiment or a trial. An experiment, the definition is it is a scientific procedure to test a hypothesis given that you know the space of all possible outcomes, specifically to probability. All right. So with that reference, we have defined one more term here, and it is the outcomes. Okay. Outcomes means that whenever you run a trial, you're likely to see some result out of it. And that is what is known as an outcome. Outcomes, it could be further divided into two categories. I'll say that the one category is that the space of all possible results that could happen as a result of that experiment. Okay. And we are interested in the count of those results that would happen, right? And the second is the favorable events that would happen as a result of that trial. Okay. And once again, we are interested in the count of those numbers. And when we know the count of the favorable, and we know the count of all possible outcomes, and we simply divide 1 with 2, that's when we obtain a desired probability of that specific event or of that specific trial. All right. So that's all about probability. It is all about defining your experiment. It is all about finding the number of your desired events versus the number of total outcomes that could happen in that experiment. And then what you obtain is your probability of that event. Now, let us take a look at some examples to build our understanding on how to calculate the probability. Take a look at this example in which the situation is that a die is thrown and we want to calculate the probability of getting either an even number or an odd number or a number 2. We want to calculate all three different probabilities. All right. So first, let us define our experiment. The experiment is simply rolling a die, correct? So this is our experiment, and the outcome from this experiment will be one of these numbers, 1, 2, 3, 4, 5, and 6. It will happen only one of these numbers, right? So in that case, we can very easily say that the count of all possible outcomes will be 6, right? So if we want to calculate the probability of an even number, it will be one of those events. Either I get a 2 or a 4 or a 6. When I get one of these numbers, you could get an even number, right? And that means that there are three possible ways the count of my favorable outcomes could happen, right? In that case, probability of my even number will be 3 over 6, simply dividing the favorable outcomes to the total number of outcomes, or that will be equal to 1 over 2, right? Likewise, we could also calculate the probability of an odd number, right? An odd number could happen if you get a 1 or a 3 or a 5, right? So there are three ways that an odd number could happen, right? In that case, your probability of an odd number will be 3 over 6, favorable to the total number of outcomes, right? And that will be equal to 1 over 2 again. And lastly, we will calculate the probability of getting a number 2 only, right? So we know that the total number of outcomes is 6. That is for sure from here, correct? Only thing we need to determine is in how many possible ways you could get a 2, and there is only one possible way that you could get a 2 because there is only one 2 in this die, right? So that means the number of ways a 2 could happen is 1, and so your answer is 1 over 6, right? So you see that it becomes extremely easy to get this number, the probability, once you know what is your experiment and you know all possible outcomes, and then you can also put a number to your desired outcomes. Okay, take a look at one more example. Alright, so in this example we are given a situation that a bag has 5 blue and 3 green marbles, all marbles being equal in size. If one marble is drawn at random from the bag without looking into the bag, what is the probability of getting a blue marble? Okay, so let's define our experiment. This experiment is about selecting a marble, right? With reference to this experiment, we say that a bag has 5 blue marbles and then we have 3 green marbles, right? A sum total of 8 marbles, right? And you can select only one marble at a time, right? So in that case, out of 8 marbles, there are 8 possible ways that you could pick a marble, right? That means the count of all possible outcomes will be 8, right? And our objective is to find the probability of selecting a blue marble, right? And in how many possible ways you could select a blue marble, because there are 5 of those in the bag. I could pick any one of those. As long as I pick one of those, it will be my required chance to obtain a blue marble, right? And I can obtain that in 5 ways. Hence, I will say that the count of my favorable outcomes will be 5. So in that case, I could easily define that the probability of this event is 5 over 8, right? So this is my required probability, right? So this is as simple as it could get. It is not at all hard to calculate the probability of any event as long as you know what is your experiment. That is the key point. You are able to calculate your desired outcomes versus the total number of outcomes, and then using this logic, this formula, you can calculate the probability of your required event. Okay, with that we will take a pause here, and that is a simple discussion on the concept of probability.